Alright guys, it's Elsek and I have to apologize for not uploading that much in a while, but never mind, I'm back and today we're gonna talk about Covenant. So Covenant is one of the cities that are originally designed by the guys who made Partial Empire, is their descendant and is the predecessor of the mythic C2. So these are pretty much made by the same guys, but they are quite different, working on a different set of tools and programming languages. I'm kind of not sure about on what Mythic is built, but I'm sure about that Covenant is on .NET. So it's supposed to be multi-platform. It can run natively on Linux and Windows, and I'm thinking of Mac because Mac has support for .NET Core, and it works pretty nice. So let me walk you through how to set up and how to basically work with Covenant. So first things first, we must obviously download and install that. So in my opt directory, I have a script called setup.bash, and what that script is doing is pretty much a wrap-up of assume breach, wrap-up of security sheets book about randomizing Covenant, and shout out to both of these guys. And what that thing is doing is whenever I do sudo and setup.bash, it's gonna first ask me to run a bunch of words which must be random, and we can say for example clown, or then let's call rain, and then for example let's see red. What that is gonna do is clone Covenant, and when that thing is being downloaded, it's gonna go through the source code of the full project and it's gonna randomize the string representing grunts, Covenant, and everything that can be flagged as signature based detection. So it makes the process a little bit easier to set up, and it makes it like having unique signatures based on your random words. When that thing is done, you saw that it's pretty fast, and our Covenant is pretty much ready. We can do .NET-V to see our .NET version, and in my case I get that annoying message saying couldn't find the valid ISU package on the system. The fix for that is straightforward. We just need to Google a little bit that, open the Stack Overflow question, and just export a single variable, so the solution is easy. What I like doing is doing that inside my root shell, so I can do sudo-i and do sudo or sudo. Never mind, I'm gonna do vim-rc and just place it here. So we have that .NET system globalization invariant equals to 1, and that's enough. So now if I go to opt and then Covenant, I do .NET-V, we can see I can run .NET commands. Version, I'm always getting that wrong the first time. We can see I'm running .NET 3.1. Now I'm inside Covenant, I need to do another one cd Covenant to navigate the .NET source code, and here there is an option to run it as a Docker, but personally I'm not a huge Docker fan and I just like doing that on my box. And now the only thing we need to do is to do .NET run, which is gonna first compile the source code and then directly executes that. It can take some time, so the idea here is that the first initial build is kind of taking like a minute or so, but it should be fast. And then it should store an interface on our local loopback address 127.0.0.1 on port 7443, and that's gonna be the UI of us accessing Covenant. So I'm gonna give it a little bit of a pause until that thing finish, and I'll be back as soon as it's done. So the process now seems to be ready, even though it hangs on create insert, which I'm not sure why, but the web page is just working fine. So if I open it in my browser and of course accept the self-sign certificate, I can see we have a clown instance there, and we need to set up initial username. So I do Kavi and type a random password there, and that's it. So that's the main UI of Covenant. So here we have user menu about us. So our user, we can change password, edit the theme, which I personally like the classic one, and that's about it. Now let's go to the fun part of the listener, launchers, and reigns in our case. That's supposed to be grunt, but we use the randomization script, so that's why it's reigns. Now here in listener, we have to do a little bit of modifications. Let's go to profile and set up a custom HTTP profile and pretty much edit that. So I'm gonna remove that and that and that. Here I can say something random like BG, and I'm gonna say that to be ASPX, and page is gonna be equal to GUID, but actually not page, but let's call it file. our file can be a little bit like sus, so let's just call it path. Alright, now we're gonna change the user agent as well. I'm gonna do macOS Edge user agent like that, and I believe it was here. Yeah, alright, I'm gonna copy that and paste it here. Now let's change the IIS 7.5 to 11 because it's the updated one. Now here we must get rid of that, and instead of I can call that thing version, and data is gonna be equal to data. And now here we need to edit the default HTTP responses and yeah, get and post responses. So here I'm gonna type, for example, I like chess, and here, but it's a hard game, something pretty random. And now on the post request, we can say like chess duel, and here let's say Q to B1 or 2. Never mind. Something completely random that just went over my head. Now let's just edit that, and should be fine now. If you take a look at it again, we have that, I think, nice. Then everything seems to be saved. An issue with Covenant I have found is that it's sometimes hard to change and modify things, but now it's not the case. Now let's go to listeners and we can create one. So now we can just give it a random name or give it ETH0, just whatever you want. I'm gonna stick with the random name. Then bind address means it's gonna listen to all interfaces. So for instance, if you have VPN connected or having multiple internet adapters, it's gonna bring up that listener to be accessible to all the adapters. Now the connect port, we're gonna stick to 80 because we're gonna be using HTTP, not HTTPS. And now the connect address is of course important because that's how the beacons would know where to connect. And now again, if you are using different adapters, you can specify their IPs. In my case, I'm using my NAT VM and we're gonna specify just that. So paste that. That automatically refreshes and we can choose multiple sets. User SL is gonna be false because once again we are still sticking to port 80, and we're gonna specify custom HTTP profile, the one we just created. So click create here and it automatically starts the Whistle interface. Now I'm not sure why it says uninitialized, but so it needed to take a little bit of time, and now it started. So if I run SS NLTP, we can see it's been listening on all interfaces on port 80, which is going to be our listener for beacons, and we have that 7443, which is the interface of Covenant. One cool part of that is we can host files here and pretty much use that not only as a callback listener, but as a like simple file server, web server, right? Now let's go to launchers and explain how that thing works. So you have different name, which depends on different set of Windows functionality. As you can see, that's designed heavily on Windows, and I think it's targeting only that. Yeah. So we have Windows utils, for example, install util, MS-build, PowerShell, of course, shellcode, which creates shellcode using Donut, binary, WMIC, and so on and so on and so on. So pretty much we have different ways of getting callbacks. Here we don't get shells, we get callbacks, and it works kind of different. So let's take, for example, the most obvious one, PowerShell, and we need to specify the listener we just created, the template and everything. We're gonna stick with the defaults and don't worry about that cert pinning there. It's for the launcher, so it works even if we use port 80. We can specify the delay before callbacks, the jitter percent, which means the randomization of seconds between the delays. So for instance, one time it can trigger at 5 seconds. If we specify a jitter time, then it can trigger at 3, 7, 8, depends on the virus. The whole idea of jitter is that it's not triggering on the exact same tick. For example, it's not triggering each 5 seconds because that's easy to catch rule on the CMs. And then we have the Q date, pretty much where the shell is gonna die of itself. And then that's it. So we can specify some standard PowerShell parameters. We're gonna leave that aside and click generate. Now here, what that is doing, it's spawning a new PowerShell and it's running a single command. which of course is huge. So let me just go ahead and copy and analyze the commands, and we can do that here actually. Do vim ps or ps launch dot text, for example. I'm gonna set paste and paste the command, and we can see it's a huge one. So on its core we have new object IO and pretty much converting from base64, and the payload is one huge base64 string there. Alright, now we can stick to that and see how that works and what happens. So I'm just gonna save that, cat ps launch, and if I were to copy that command to my, come on, cat ps launch to my clipboard with Excel, go to my command VM and spawn a simple PowerShell window there, and paste that thing. Let's see what's gonna happen. Nope, not that. Not sure why that is, so let's do it. I'm not sure why my clipboard is not shared, but let's do it the other way. So I'm gonna do Python 3 m http server 8099. I'm just gonna copy that and believe it's gonna be copied, so 91.135, and here I'm gonna do IEX, new object, net.webclient, download string. Did it save? No, it did not. So let me try HTTP 91.135. Yeah, looks like. And then let's specify the port 8099 and then close the brackets. Now if I run that, we see a strange behavior because I did not specify the file. So ps launch that text, and now the shell hangs and restarted. Not sure why. So let me just go to my commando and go to Venice, and we can see something happened. So it's on stage 1. I'm not sure why exactly the shell restarted and the process was not able to complete.
One eternity later.
So after a little bit of debugging, I found what was missing, and that was our HTTP profile. I want to interrupt my own video by saying what exactly went wrong. So pretty much on my listener and profile, on the custom HTTP profile, we get rid of that data variable which is needed, because here, without specifying that data, the Covenant do not know how to use that HTTP gets and response, and that's why we are getting errored out. That's why we get untrusted, because the Covenant beacon do not know how to transfer its command and its output. So by staying with the current template, well, the previous one we did the custom HTTP profile, by importing that data is equal to something here, here, and here, we were able to make it work again. So on Rain, that's my callback from my commando using the PowerShell code. So moving on. We messed up with that, and that's why on the listener tab I created a new profile called HTTP. Now here the default, I stayed as much as I could with default setting, changing a little bit the signatures. So I did index.php ID is going to be equal to GUID. I left that as it is. Then we have the default user agent, which I believe is not the case. We were untrusted, but actually it can be the case. So let's test and stick with that user agent right now. Then we have the server, which is going to be the same, then the variable, and then the post idea. The HTTP get response is going to be idea data, then the HTTP post response is going to be post idea data, and I can say equals here. Yeah, so that's my HTTP profile, the new one I did. Now let's go to listener, and I just created a new one having the same settings, specify my IP and specify the profile. Now inside launchers, I generated a PowerShell using the exact same steps, and I have that payload which I stored on variable called launch.text, like that. To invoke that, it's of course needed to set up a simple Python server, and why I stick with Python is because I wanted to see what is going on and if the machines can see each other. But now actually we can do the Covenant hosting. So inside listeners, go to host files, create, and type launch.text, which is gonna be pretty much the file name. Then click browse and host that. Now it's automatically being hosted, and whenever it requests something from that port, it's gonna get executed. So I'm gonna open a new PowerShell window there and type, come on, my previous command, which is gonna remove the port to be 80, and that's about it. Run that. Now we can see the shell hangs. Then if we go to my Kavik box, we can see a pop-up which saying rain is being activated, which would be grunt, and pretty much this is the beacon we had. On the rain tab are all the beacons we have actively running, and of course hidden, you can see hidden ones with that. And we have the name, we have the ability of engaging directly from here. Then we have the host name is going to be commando, user, and integrity level. The last check-in is the last time the beacon asked for a command, and that depends on your delay and your jitter time. Then on the name, we can, as I showed you, interact with the little shell icon here, or open the grunt itself, which in our case is rain, and click interact. Now on diff we can hide that, but we don't need to do that now, and go to interact. Now that spawns a custom shell. That's not a native Windows shell. For example, I cannot run commands like ipconfig, and that's its idea. So when you're having such situ, you're not expected to have a cmd.exe shell, because that's pretty much easy to get caught, but you have some unique kind of shell having some unique set of commands and set of utilities. The thing here is that you can pretty much do whatever you want with that shell, having a little bit like a more strange way of work. For example, I can execute shell commands by specifying the syntax shell cmd, and then run ipconfig, and that's gonna spawn cmd.exe and it's gonna spawn ipconfig, and we can have the output here the next time the beacon triggers. So that's the way of executing native shell commands. Alright, what about PowerShell? Well, we have PowerShell module here, and we can do PowerShell GCI. Alright, but what about importing PowerShell script? That's easy enough. We can do PowerShell import and pretty much navigate to our script, and it's gonna get imported in our current session. And then after we import the script, we can invoke it again with PowerShell and the command itself. For example, we import PowerView or PowerUp and then do PowerShell and audit and so on. The next cool thing about that is I can go and run assemblies there. So it overruns from memory, so we don't have to worry about doing that type of thing. So if I go and run assembly, and for example we want to run that WinPiece thing there, I'm gonna call the file ASD, and I will not provide any argument because I don't need it. But if the binary you want to run is requiring arguments, you can pass them here. When I click execute, it tasks the command, and the next time beacon triggers, it's gonna run the binary inside memory, and we're gonna have the output there. We can also minimize the commands in the outputs, which kind of makes the thing organized, and it keeps a nice history. So imagine this shell dies, you can go back and navigate to the already dead shell, and you can see the commands that will run at what time and the output of the commands. So after we run the assembly, we can see the WinPiece output is up and running. I know that that's an annoying thing about pretty much having that colorization in WinPiece, which is kind of bad because it did not parse the colors, and we have that bunch of strings there. But I guess we can use the colorless version of WinPiece, or use the WinPiece bat file, which again does not have colors, as I believe. And pretty much that's how you can run assemblies in memory. So we have all the functionality of the stable reverse shell, like we can run system commands, we can run PowerShell, and then we can run assemblies, and that thing is going to be all in memory. Of course, we have more syntax like run as cmd, shell cmd run as. We can directly invoke Mimikatz. So whenever we have a beacon callback, we can go ahead and directly invoke Mimikatz without importing anything or without running the assembly file. It has a built-in functionality inside Covenant, which I think is great. Of course, we have more of one ways of achieving things. Depends on your target, your enumeration, and the way you want to do things. For instance, we can go with msutil, msbuild. We can go with shellcode, generate the donut shellcode, and that's gonna and we can use that to, for example, some kind of a custom stager like the one we built on C, or someone in Python or C#, I don't know. Then we can go with binary, and it's gonna be really simple dropper, which of course is getting detected by anything. We can go with WMIC and MSHTA, and we can, for example, determine if we want to use the scripting language of JScript or VBScript. So I think that thing works pretty nice, and to be honest, I'm starting to be a fan of Covenant and to start enjoying that and implementing that in my tasks on work or any kind of such related things. So that was the video. That's how you pretty much interact with Covenant. That's how you use the shell. That's how you use the beacon. And of course, feel free to improvise on all these techniques. For example, on the launchers, we can create a simple stager, go there, implement AMSI bypasses. And the cool thing about that is that after we AMSI bypass and trigger the beacon, everything is gonna sustain that AMSI bypass, and no matter what we run, it's gonna be under no AMSI, which is nice. And just feel free to improvise on that and see for yourself what works, what not, and go down in the comments saying why do you like Covenant or why do you don't like Covenant. I'll be looking for your answers. So thank you so much for the watching, guys. Hope you learned something new, and I'll be seeing you in the next one.